All right, let's get into it. So we got find the exact value of theta. We're solving equations within our domains. Our domains meaning within our restrictions. I like to think of domains and restrictions almost synonymous of each other. So we got this guy right here. Now, what do you think would be the first step to do? Well, the first rule, you would take the arc sine of it. And now once again, I want to emphasize, you can do that. You can write it this way, or you can write it this way. Entirely up to you. I write it that way because I'm more accustomed to that, but they both mean the same thing. They're just two fancy ways of writing arc sine. So the first thing that happens is that comes here, leaving what's in the argument in the parentheses by itself. And now you have arc sine because it got shifted over to the other side. And the new argument is whatever's already there. You feel me? That is all that is happening. Nothing else, nothing more, nothing less. Now, if we take the arc sine on a calculator, or if you look at your unit circle, you would see that arc sine of 1/2 is pi over 6. Not a big deal, right? Or 30 degrees. We're doing everything in radians right now. So, basic algebra. Divide both sides. I'm sorry if there's like weird sounds up there. Theta equals pi over 12. So now that we know 1, where else would this be? Well, the other place would be, and once again, we became a unit circle while I'm pulling all these numbers out, by pi over 12. Yep, or 15 degrees and 75 degrees. You could think of it in degrees, but we're doing everything in radians. Now, let's do another one. They look kind of challenging. I'm not going to do too many of these because they're not really that bad. I think once you kind of get the flow of how it works and the little rules, you can kind of figure out how to do each one. So let's try this one because this one might look scary to most. So we're going to take the arc sine, or actually we can flip this. Let's do the inverse. So as you know, sine equals cosecant, right? That's the inverse of it. Cosine, the inverse of that is secant. Oh my God, I'm like drawing a blank. Tangent, the inverse is cotangent, right? So just take a moment to review that stuff in case that sounded kind of foreign to you. So let's take we're going to simplify this, which this is an actual identity, which would be negative cotangent of theta equals 1. So this big thing, yes, becomes that. Now, remember, I'm going to be honest with you. This is how I remember it, because it's really not that hard. Whenever you have theta minus pi over 2, you can switch it to that. Whenever you have a theta, you can switch it to that. And it doesn't matter if it's sine to cosecant, that's what it would be right here. If it is cosine to secant, it would be that thing. So if you had secant of this, reversing would be that of cosine. You feel me? If we have tangent of that one, it would equal the cotangent of that one. You feel me? So that's all we're doing. I try to make everything simple. I know there's a deeper mathematical explanation for it, but honestly, unless you're going to be an engineer, you really don't need to know this. I'm pretty sure most people watching this is just like for math. So we're going to take the arc, what we did here, arc cotangent. So we have negative theta, right? The negative stays theta there. Cotangent, arc cotangent of 1. So the symbol, or the trigonometric ratio, jumps there, leaving whatever's here and here behind. And then this thing becomes a new thing in the parentheses. That is all that is happening. And that would be theta equals 3 pi over quattro, or 4. So not too bad, or 135 degrees. I'll tell you how you want to think about it. How do you like convert, once again, 3 times, and every time you see a pi, think of 180. So 3 times 180 divided by 4 will give you whatever degrees that is, by the way, if you want to convert back, which in this case, 135 degrees. Let's see what else we got on here. I'm going to try to kill, okay, using a calculator. Okay, tangent, and then negative 2. We're not going to go over these because these you get to use a calculator. No solution. This, oh, not an identity. Okay, let's try this one out really quick. If it was cosine squared theta and plus sine squared theta, it would equal 1. So then I would be like, yeah, there is a solution. But let's solve this. Obviously, it says no solution, but let's see why there is no solution. I'll write it up here, just for space. Plus sine theta equals 2. thinking. Okay, this is an identity. We could turn that into 1 minus sine theta squared. And as you guessed, this one would be kind of, if this was squared, it would be like 1 minus cosine, you know, whatever. Actually, I'm going to put the squared right here. It means the same thing. It really does. Oh my gosh, why did I do that? There we go. Sorry, I just want to erase that. I like to keep it here rather than there. I just don't like it on that side. I know some people write it that way. It kind of throws me off, to be honest. Plus sine of theta, because this is going there, equals 2. That's going there. So the only thing we did was this became that. Okay? Nothing crazy. And if you are struggling with identities, just Google trigonometric identities. There's like hundreds and hundreds and hundreds, and the more of them you know, you don't even know hundreds, but just honestly knowing 10 or 12, you can pretty much derive them and figure the rest out. So now I'm going to substitute them. So what does that mean? 1 minus, I'll use a y. That's a y squared, because that's a squared, plus y equals, oh, sorry, put that to both sides. Let's do that real quick. Basic algebra steps I'm messing up on. Minus 2 equals 0. We got to make it all equal 0. So I just put that 2 into here. So negative 2 onto both sides, canceled out right there. Cool. And now, well, if we were to solve this equation, yeah, we wouldn't be able to because of this. I mean, I could solve it right now, but I don't really need to. This is to the 1 power. Yeah, there would be no answer. So, no solution, or error, or, yeah, that's basically, yeah, there is no solution to that one. So that was good to know. That was a good little practice round. Let's see what else we got here. Let's go down, let's go down, let's go down, let's go down. Oh, isn't it? Oh, is that really it? Solve each equation on the interval of, didn't we do these already? Whatever, we'll do one. Because once again, this is like basic, it's not crazy. So I think we did do this one already. Well, let's just do it again. So we have 2 sine of theta plus 3 equals 2. I'm going to change it to 2x plus 3 equals 2. And yes, you can do that. So look, minus 3, boom. That's done. 2x equals 2 minus 3. 2x equals, what would that be? You got it, negative 1. 2 to both sides. X equals negative 1/2. Let's substitute back that sine for x now that we did all that work. So sine theta equals negative 1/2 using our unit circle, arc sine. So remember, arc sine, that goes over to that side. So it would be theta, because that stays behind, arc sine of the new argument. Now, where on the calculator you could use it, or you could just use a unit circle. Theta would be negative 1/2 at 2 places, if I'm not mistaken. Let me look real quick. Yeah, okay. You kind of start feeling for it. Wonderful. So at 330 degrees, so 11 times 180 divided by 6, 330, that's how I converted it. 7 times 180. Also, I have the unit circle. I'm not doing all this math really quick in my head, by the way. Or in radians, up to you. I'm pretty sure your teacher wants it like that. So that's about it for that one.